Okay, let's get started. So, there's a little bit of housekeeping here. One is that I've decided to change my office hours. So, it's just too much for me to do lectures and office hours on Tuesday, Thursday. It's, for some reason, doing this at home um, is much more tiring than actually coming in and standing up and talking in front of a class. I don't exactly understand why that is, but so so since everything's virtual anyway, I thought, well, I'll just have my office hours on Monday and Friday instead of Tuesdays and Thursdays. It's not like I'm doing anything else on Mondays and Fridays. So there won't be an office hour this coming Thursday. Instead, the office hour will be on Friday. Let me know if that's a problem for you. You can always arrange private meetings, even on the weekends, as long as this quarantine is going on. Along those lines, okay, good. Along those lines, Jedi 1.0 is due Friday night. So, so I'm hoping to we can, at least in terms of like the lecture, put any finishing touches on Jedi 1.0 in the next couple of days. I'll spend the beginning of the class. I'll say a few words about it. I have more than a few words to say about it. But, also this would be like during this lecture, this would be a good time to ask any questions you might have about it. And let's see, because I would like to, we got to get moving here. I would like to start talking about Jedi too. Okay, let's see. Let's do a screen share to our little Yoda guy here. I'm just waiting for George Lucas to sue me for using Jedi. I don't want those characters. Because it would be Disney that would sue me. Why is this taking so long? It's taking an oddly long period of time to download. What's going on? Oh, okay. Let's look at the local version of it. Was that going to the same place? Yes, it's going to the same place. I do have a local copy of it, which see if I can find the local copy of it. Sorry about this. Come on. Still not quite there. All right. Okay. So, and let's see, am I sharing still? Yes, I am still sharing. Okay. So last time we talked about parsing. Okay. And I'm going to come back. This is the Jedi 1.0 thing. Here is the lectures about all the details of parsing, as well as like a start on the parser. I'm going to summarize, though, by coming down here this flow of control thing. Okay, so we've seen the first part of this diagram earlier. this is a little interaction. I've defined x to be 3, and now I'm calculating, hey, what's x plus 2? And this is a UML sequence diagram. It's tracing the flow of how x plus 2 gets executed in Jedi. These boxes at the top are UML icons representing objects. So here is a console object, a parser object, expression, integer identifier. So the yellows are, I guess, expression instances, things of type expression. Here's the global environment, and here's the ALU. And so I won't go into too much detail here. We've already done it, but here the input from the user is just the string x plus 2. Expression here, this is the expression parser. Let's parse x plus 2. And so he says, okay, well, that's going to be a fun call. And then he has to parse the x and the 2. The 2 is an integer, the x is an identifier. And then, so he creates this expression, and here comes the expression back to the console. The console then asks the expression, please execute yourself, and we'll use the global environment. Okay, but executing an expression is a very recursive affair. You have to execute your component. So he executes 2. What's the value of 2? Well, it's 2. He executes x, this is x, and x has to go into the global environment and look up x, look itself up. And here it finds out, oh, well, I'm equal to 3, so he returns 3. And now he goes over here to the ALU and he says, please add 2 and 3. So here comes 5 back. And then he returns to the console 5, and 5 gets printed to the screen. And so that's pretty much it for all expressions that get typed in, the flow of control, the dynamics of it. Now let's look at parsing. This is, here is the first line of the parser. So this is from parsing. So I'm defining the expression parser. And remember what he does, he first attempts to use the declaration parser. If that fails, it doesn't look like a definition of something. He says, okay, well, maybe it's an if-else. So he tries the conditional parser. If that fails, he then tries the disjunction parser. If that fails, this thing here is like some sort of a failure message that goes back to the console, and the console prints out some sort of syntax error. Okay, so here it is. This is a UML activity diagram. These little rectangles here, rounded cornered rectangles, are activities, and these little diamond things here are decision boxes. So it starts by making this first decision. Was it a declaration? That's what this guy's doing. If so, we create a declaration object. Declaration is a subclass of expression, so we've created expression. If it wasn't a declaration, else, was it a conditional? So we'll create a conditional. Otherwise, we come down here, and was it a disjunction? We're going to parse disjunction. And that little dumbbell there means that this activity is actually a composite activity. Okay, so it's got activities inside of it, which we'll look at in a moment. Otherwise, we come down here and fail, and that's the end. Now we go inside of parse disjunction. So that was this bubble here. We ask ourselves, okay, was it actually a disjunction? Did it have or symbols in it? Okay, if so, then we created disjunction. That's another class. If not, we ask, was it a conjunction? So there are no ors in it. Maybe there were ands in it. If there were ands in it, the little double ampersand sign, then we'll go ahead and create a conjunction. Come down here. Maybe there were no ors, there were no ands in it. Well, was there an equal sign in it? Okay. Well, here we're going to create a function call. And that function call is to the equals function. The equals function is one of the functions that the ALU knows about. Maybe there were no equal signs in it. We come down here, well, maybe there are inequality signs, less than, greater than, or not equal. Okay? If so, then we're going to create a different fun call, either to the less, more, or unequals function. Those are also functions defined in the ALU. Maybe there were no inequality signs in it. Well, was there a plus or a minus sign in it? If so, it might be a sum, and we'll come over here and we're going to create a fun call to the add function. The add function is, again, something that the ALU knows how to do. No add signs? Well, we'll come down here. Maybe there was times or divide signs in it, in which case we're going to create another fun call. Fun call is a subclass of expression to mul. Mul is one of the functions that the ALU knows how to do. No multiply signs? Well, we'll come down here. Probably it's a term, so we'll try to parse it. We'll call the term parser. How are we doing? Is everybody liking my activity diagram? I think they're pretty cool. Activity diagrams are kind of like the new flow charts. Yes, okay, thank you, Brianna. So notice that this is a composite activity. It's got sub-activities in it. We'll come down here, and now we're inside of parse term. Maybe it was a function call. What does a function call look like? A function call is an identifier, a name, like add or something like that, is an identifier followed by a left paren, followed maybe by some operands, and then followed by a closing right paren. So that's the syntax for fun call. So if it was a fun call, okay, we'll create a fun call. Okay, but maybe it didn't look like a fun call. Well, what could it be? Well, maybe it was a literal. Okay, so we'll try to parse literal, and that's a composite activity. Or maybe it had this form. So this is an expression with parentheses around it. If so, we'll call parse expression. Well, that's the top of the tree. So we'll go all the way back up and parse that expression. Parsing expression, this low down, is only for expressions that have parentheses around it. Remember, the lower in the parser you parse, the lower in the parse tree, the earlier it gets executed. Because, these parsers are producing a tree. You can think of the expression as a tree. And then when you execute a tree, you execute the children before you execute the parent. That sounds grim, doesn't it? And so the tree is executed from the leaves up to the root. So the lower you are on the tree, the sooner you get executed. And that's why some types of expressions have higher precedence than others. And so an expression with parentheses around it has a very high precedence because it's so low in the tree. So then parse literal, what about that? Here's parse literal. Maybe it was a bool. Okay, well, we'll create a bool. Maybe it was a real, we'll create a real. Maybe it was an integer, create an integer. Maybe it was text, create a text. And then lastly, maybe it was an identifier like X, Y, or Z, in which case we'll create the identifier. So that is the flow of control through the parser. If we go look at the parser again for a second, Jedi 1 parsers. Here I gave you a little head start on it. So hopefully, you're not having any problems anymore with using the parser combinator library. Here's the expression parser here. It calls declaration parser, conditional parser, disjunction. I've given you the declaration parser. I've given you the conditional parser. This is if it begins with an if. And I've given you the disjunction parser. This is for ors. Remember, it should look like a conjunction followed by, we have an or operator and another conjunction, and that's repeated 0 or more times. So if it's repeated 0 times, remember the output of rep is a list. If the list is nil, then it was just a conjunction. If the list wasn't nil, then it was a disjunction. And here we'll take the con, this con here is the output of the conjunction parser, and more is a non-nil list that is the output of this repetition. And so we'll take con and we add it to the beginning of the more list. And now we've just got like a big list of conjunctions, and we feed it to the disjunction constructor. And then I've given you, so you're going to basically copy this. I've given you informally the grammar rules for conjunction, equality, and inequality. Okay, and so you can kind of copy those things. The inequality is a little bit different than equality. So equality is, you read this, is one or more inequalities separated by equal signs. But inequality is a sum by itself, or a sum possibly followed by one of these inequality operators followed by another sum. In other words, inequalities are binary, right? It's you're comparing two sums using less than, greater than, or not equal. It's not a list of sums with inequality operators between them. That's too confusing. Right? And so that's expressed by this question mark here. Remember, that'll translate into OPT. OPT returns an optional expression, either a sum or a none. Then here's my sum parser, and this was real tricky. I had to like chain subtractions into additions of negative numbers. So that was a little bit tricky. I don't think I'm going to go over that again right now, unless somebody wants to a little bit later on. I think that works. I think that you don't have to worry about it. You should have to worry about it in the sense you should understand it. And where is my product parser? Yeah, here's my product parser. My product parser is using a slightly different technique. So remember, we had this problem of precedence. If you have like a plus and a times inside the same expression, we want to do the times before the plus. Okay, that's just a convention, by the way. But what happens if an expression contains two operators of the same precedence, like 3 minus 4 minus 5? Which one of those subtractions do you do first? They have the same precedence. How do you choose? And so programming languages have what is called associativity rules, left to right or right to left. So typically for addition, subtraction, multiply, and divide, it's left to right associative, which means you do the leftmost one first and then the right. You go from left to right. Okay, and but these two parsers, sum and product, demonstrate two ways to enforce left to right associativity. Here we have the term parser. It's going to try using a fun call, then literal, or maybe it's an expression with parentheses. Okay, so I think that's complete. You're done with term. Here's literal. Try bool, try real, try integer, try chars, try identifier. Okay, I've given you chars here. So all of these guys use the regular expression feature. Okay, I thought I gave you another one. Oh, maybe I just did it in code for you. But basically what you do is grab this regular expression, okay, and put it in triple quotes with a .r after it. Okay, so I've kind of done that here, and then transform it. So if it parses, it gives you a string. In this case, you transform the string into an integer. Here, if it matches this pattern, you transform the string into a real. If it matches this pattern, you transform the string into the bool true or the bool false. If it matches this string, you transform it into an identifier with that string as its name. And then finally, here's fun call. Fun call is an identifier. We have identifier just above it, followed by operands. Operands, this is the only thing that's a little bit different. The operands parser produces a list of expressions. So here, operands starts with the left paren, and it closes with the right paren here. And inside here, what this rule says is it's 0 or more expressions separated by commas. Okay? 0 or more expressions separated by commas. And so here you want to generate a list of expressions from this. And another thing that's important is that even if there are no inputs to a fun call, you still need the left and right parentheses, the empty parentheses. So we're a little bit deficient compared to Scala in that regard. We need those parentheses to distinguish a fun call from an identifier. How are we doing? Questions? Okay, so how is fun call described again? So do a quick screen share with that's not what I want. All right, so here are the forms of your fun calls. You can have so this first fun call, let's see if I can crank up the font size. I'm so proud of myself for knowing how to do this on TextPad. So this is no inputs function. So those sometimes happen in programming. This is an example of a function with one input, function call with one input. Here's a function call with 3 inputs. Of course, you could have 50 inputs if you want. Notice here I have to bust out the commas to separate the inputs, the operands. Okay. And so your expression parser looks like this. Let me just cheat for 1 second. Go back in. Expression, your fun call parser looks like this. I guess it makes a fun call. Here we make a fun call, and then here identifier, of course, is defined earlier. Kind of guessing a little bit on the syntax here. Grab the rule that I gave you. Looking for my parser. Okay, so the only thing I have to change here is they don't like question mark. Well, I have to change a couple things, don't I? So here they don't like star. And so I have to change that to rep. Go out here. They don't like question mark here. That's going to go out here to OPT. And so operands is the only one that's different. It doesn't produce an expression. It produces a list of expression. Okay, and it should be pretty easy to do. So this is going to either be a sum or a none. So if it's none, then you would return. If this was none, then you would return the empty list. Okay, this is just empty parentheses, right? If this was sum, then you go inside and you're going to expect to find an expression followed by like another list. Remember, rep produces a list. So if rep list is nil, then this is going to be just a list consisting of only this one expression. Otherwise, you take this, the output of this guy, the expression this produces, and the list this produces, cons this onto that, and that's the list that you return. Is there another question? Okay, good. All right. Let's say a few words about, let's say a few words about the ALU. I want to make sure that you understand that. The ALU is kind of another tough part of getting Jedi 1 working. Really want to get Jedi 1 working here too. So this is the code that I've given you. The top level guy is this execute guy, and he takes an opcode, so that's an identifier of some sort. And then args is a list, not a list of expression, but a list of value. And the return will be a value. Right? And so here we do opcode.name match. Remember, that's a string. And then this is called a dispatcher. Okay, so if it's add, then we'll call add. If it's mul, we'll call mul, subtract, division, less, more, equals, unequals, not. And then here I have write, prompt, read, and then underscore is where I throw an undefined exception. I've never heard of this function before. Okay, I think I've completed add for you. And I've got like a few models here that we'll go through. Okay, and then let's see, what else did I do? I've completed less than for you, so that's another model. And then here's write, read, and prompt. Okay, so write, read, and prompt, I don't know if I don't really ever use read and prompt, but write takes a list of values and it prints out val sub 0. So write really just wants one, this list should just have one thing in it. So I'm going to print out the first thing, and then I return notification.done. Okay, read reads in something, like if you wanted to do some like little interactive console program inside of Jedi. You could use this read and prompt, prints a prompt for you. So I was thinking of creating a console inside of Jedi, although I've never done that. But right here is very useful for doing debugging. Okay, so here are your two models. Okay, add, and here's like the add function. To args is a list of values. Okay, and we have to produce a new value. Now, add is complicated for several reasons. There are really three add functions. And it makes sense to add integers. It makes sense to add reals, and it makes sense to add strings. Adding strings is string concatenation. And remember, like every time plus always parses into add. Like if it was a, if it's a sum, you're generating a fun call to add, okay, which is ultimately going to call this add method here. Okay, and then another complication is that it makes sense to add together a mixture of integers and reals. Okay, so I have to deal with all of those complications here. Okay, so I'm going to take this args, and that's a list, so I can use map with it. And I have this function toInt. Take a look at toInt. ToInt takes an arg here. It says if arg is an instance of integer, then he is going to cast it as an integer instead of just a value and put it inside of a sum. Otherwise, he returns a none. Okay, so args2 is going to be a list of optional integers. Okay? If args2.size is the same as args.size, then that means that everything in args was an integer. Okay, and so what I'm going to do is, what do I do here? So args2.flatten. Flatten is like another one of these built-in functions. It takes a list of sums and gets rid of the sums and just tells you what's inside the sum. So if the args2 was sum 3, sum 4, sum 5, this would just turn into the list 3, 4, 5. We're flattening it out. We're getting rid of, we're extracting out all the values. And then reduce plus. This is the plus sign from Jedi 0, right, that you define. So it adds together these Jedi integers. Boom, we're done. Here, this else, well, args2.size was not the same as args.size, which meant that there were some things in args that weren't integers. Okay, it could be maybe they were all reals. So here, I'm going to do the same thing. I'm going to map everything to real. To real is up here. So if it's an instance of real, then I return a sum. If it was an instance of an integer, then I convert the integer to a real and return a sum, otherwise return none. So toReal can work with a mixture of integers and reals, okay? And it just converts, so if it's like 3.1, 4.2, and 5, it'll convert it into 3.1, 4.2, 5.0. Okay, so it converts everything into reals, and then it's going to add them. Together. And then finally, maybe it was a list of strings. Okay, so if it was a list of strings, then I do the same trick. I convert them all into strings, optional strings. I flatten them, and then this plus sign. Did we define plus for append? I'm assuming that append is called plus in your chars class. This is the plus from your real class. Okay, and then finally we come down here and we complain inputs to plus must be numbers or text. So very complicated. You will be copying this for multiply. And so multiply looks just like this, except that there is no strings in multiply. We don't have any concept of multiplying strings together. Okay. Right. Let's take a look at less. So less than parses into less, which calls this less function. Okay, and here, remember I said less greater than, not equal to, only two arguments to that. Okay, so if args.length is not equal to 2, then I throw a type exception. Okay, otherwise, I'm going to do the same thing here. Less than makes sense for strings, for chars, ints, and reals. So I do the same thing. I try to convert them all into integers. Okay, and if they are all integers, then I compare args2 sub 0 and args2 sub 1. And that'll be either true or false, and I convert, that'll be a Scala true or false, and I convert it into a Jedi true or false. Why is I have private and not less? Great question. That is because I am a big fat dummy. That should be private. Nobody's got any business calling these functions. You know, if you want the ALU to do something for you, you only call execute. So I should have declared those private. All of these should be private down here as well. Okay. You know, and again, this is complicated because it makes sense to compare reals, integers, chars, and it also makes sense to compare integers to reals. Okay, so you'll copy this code for, I think the function is called more, and maybe maybe do we have to do not equals to? Let's see what I've got up here. If there's less, more, equals, what is this note here? Equals 7, comma true, equals false. Oh, yeah, it makes sense. So this note here is saying it makes sense to compare things that aren't of the same type. I mean, is 7 equal to true? Well, no, it's not equal to true. You know, so this is not a type error, right? It makes sense to compare, you know, things that are of different types. It's just the answer is always false. And here is unequals, okay? And that's binary too, only two inputs. And you could maybe try doing something like this. Not is unary, okay, just one input. Now, here's something I want to emphasize. This will be important. The cool feature that Scala has that Jedi doesn't have is static type checking. It means that we check for type errors before we execute the expression. So you find out what went wrong, you know, before, you know, your rocket ship blows up on the launching pad. Okay. Jedi uses, this version of Jedi uses dynamic type checking, which means that the type checking goes on at the time of execution. Okay, most of that type checking happens in the ALU. Okay, that's why all of this focus on types, we're always throwing type exceptions all over the place here. So this is 90% of our type checking for any kind of a fun call happens in the ALU. So you have to be super diligent about checking for any errors. And type errors could be the wrong types of inputs or the wrong number of inputs. So I want you to check for both of those things. Do all of the cases say no? So he's asking if they all take two inputs. No. If it doesn't specify binary or unary, then they are what are sometimes called n-ary, which means that they can take 2 or more inputs. So you can add together any number of numbers you want. So these guys, I mean, even divide. So 3 divided by 4 divided by 2, right? Remember, it's left to right associative. So it makes sense to, these lists can be arbitrarily long. The only binary ones are less, more, unequals. I think not is the only unary one. Oh, no, right is unary. And I think prompt and read don't take any inputs at all. And here I'm being very bad. I'm not checking. I should have checked here to make sure that vowels only had one input in it. And here I should have checked vowels should be empty. I shouldn't be seeing any vowels. And prompt all vowels should be empty here. So these are zero array functions. Let's see. So psi, do all the cases and execute only take 2. So for equals, we could check if multiple things equal each other. Yeah, so the algorithm for equals, so that's a good question. So here we have equals, and it takes a list of things, okay? And here's like the cool way I think to do it. You should go through the list and make sure that everything in the list equals the first thing in the list is the easy way to do it. Okay, if everything in the list equals the first thing in the list, then you return true. But as soon as you bump into anything in this list that doesn't equal the first thing in the list, immediately return false. Don't even bother to continue looking on, because if you have multiple equals, if you have x equals y equals z equals w, right? That's the same as x equals y and y equals z and y equals w. So we want to have that short circuit execution there. Okay. All right, good. Now, this could be very embarrassing, but I'm going to try it anyway. Down here, I've given you this Jedi 1 tests. Okay, and so what I'm going to do is see if I can get this to work. Think about it for a moment. Paste it into a text file. Oh, no, I'm sorry. This is the wrong place to do it. Start all over again. So I copied this. Okay, so watch how this works. I'm going to go to Jedi. This is my Jedi. Okay, now I'm going to click on the Jedi project, go up to new, and say create a new file. File name is going to be I'm going to paste in this test code and save it. Okay, next. Oh, can't see my clips. Okay, sharing. Start all over again. Really, feel free to speak up too. So what I did here was I right mouse click on Jedi, come down here to new file. Okay, I called it Jedi, I'll call this Jedi 2 tests. And then I pasted in the code that I gave you. Okay. Next, I'm going to right mouse click on this guy and go to properties. No, not properties. Wait, let me try that again. Right mouse click 10 here. Come down to run as, run configurations. Okay, and here's run configurations, and there's a tab here called arguments. I'm going to type in Jedi 1 tests. Now I'm going to run it, and this could blow up. I just like quickly sort of put together this code. Okay, and so what happens here is that configurations, let's go back and look at configurations. Where was that? There's a couple of places to get to this. So arguments, these are command line arguments. They call them program arguments here. And if we go to console, we scroll down here, that is args. So this is an array of strings, just like in Java. And this is like the command line arguments. And so if args.length is 0, that means there were no command line arguments. So I just call REPL. We go into interpreter mode. Otherwise, arg sub 0, that's going to be the name of that file, and I call execute file. Execute file is up here, and basically it just reads in each line from that file. It reads in the line, and then it executes that line. Basically does the same. Right here, we just execute that line by line. Okay, so then I come back here. So here, the expression, here was the line, the first line. Okay, I'm defining sum to be whatever this expression is. And this is a definition, so it just returns a notification. Okay, I did it. Really? Are you sure? So I type in sum, that's an identifier, and it says sum is now 20. Let's just check it out. 3 times 4 is 12. 9 minus 1 is 8. 8 plus 12 is 20. Hey, that's right. Hey, me. Here's the next test. What about 3 times 4 plus 9? It says 21. Let's check it out. Multiply should have higher precedence. So 3 times 4 is 12, plus 9 is 21. Here we have 3 times the quantity, 4 plus 9. Right, so that's 13 times 3 is 39. Here I'm doing mixed. So this is 3 plus 4.0. And here the answer is 7.0. Notice that the answer here, because all of the inputs were integers, the answer is an integer. But just one input being a real makes the answer real. And here subtracting 3 and 4, so negative numbers are there. Subtracting 3, this is 3 minus negative 4, which is the same as 3 plus 4, so we're getting 7. Here's 3 minus negative 4. Okay, so that's just the same as 3 plus 4. 2 minuses make a plus. Defining pi here, here's another declaration. They just return okay. And now here's pi times e plus sum, and I'm not going to go through the math on that. Hopefully that's right. 3 is less than 4 is true. 3 equals 4 is false. 3 is not equal to 4 is true. And here is 3 if sum is less than 19, then 8 else 3. Well, sum is 20, right? 20 is not less than 19, so this returns 3, and 3 plus 3 is 6. And here, if sum is less than 19, then nada else 3. Okay, well, nada, there's nothing called nada. It hasn't been defined yet, right? But we still get the answer 3. And that's because conditional execution is a form of laziness. It doesn't execute both nada and 3. Since this condition is false, it skipped over nada and just gave us 3. Here's conjunction. 3 is less than 4 is true. 1 plus 1 equals 2 is true. Sum is less than 19. That's false. So boom, I'm done. The answer is false. I never got to nada, which would have given me an undefined error. Here is a disjunction. 4 is less than 3 is false. 1 plus 1 is not equal to 2 is false. Sum is less than 19 is false. True is true. So boom, I'm done. I return true. Short circuit execution. I never made it to nada, which would have given me an undefined error. And now we're done. Okay, if you want to go back to interactive mode, right, then let's see, there's another way to do this. Get to run configurations. You can get to it here. You have to go back to arguments, get rid of Jedi 1 tests. And now we're back to notice what happened here. This hello world is not the value returned by write. It's a side effect created by writes, which is namely print hello worlds to the console. Done is the notification, which is actually returned by writes. So you can use this test file, and it makes it really quick to test your Jedi. Right, and what I'm going to do is I'm going to supply the grader with a similar file, not exactly the same, but similar, okay, filled with all kinds of little challenges. And what he'll do is you'll turn in your source code on Friday night. You'll upload your source code, just your source code, please. Don't upload your binaries or all that other stuff. You know, and he'll have a little Jedi project set up, and he'll import your source code into it. And he'll have like a test file set up, and he will run it and just check to see if you got like all of the, if you had all of the right answers. Okay, but make sure that it works on the test file that I provided for you. How are we doing? Questions? Okay, so special form. Let's talk a little bit about special form. Let's see. So first of all, maybe we'll go here. Okay, so I introduce special form. It's just a trait. It's empty. I'll show you my code for it for a moment. And it doesn't really do anything. It just serves as a way of collectively referring to all types of expressions that have some kind of weird execute algorithm. By weird, an example of weird execute algorithm would be a lazy execute algorithm. So conditional, conjunction, disjunction all have lazy executes, or a side effect. The execution produces a side effect of some sort. So that's what declaration does. Right, so here under expression, this is my definition of special form. That's it. Right? If we look at declaration, remember all classes, all of the classes in the expression hierarchy are case classes, okay, which means that they automatically get like a companion object. Here is the identifier, and here is the expression. So if this were And so here would be something that you might type in to the interpreter's prompt, right? And this is going to create a new instance of this declaration class. Ident is the identifier X, and exp over here is going to be this adds 2, 3, which is a fun call, right? And so, right, and all you're doing here, right, is you execute the expression, which is going to be 5 in whatever this environment is. And then you're going to put into the identifier, you could even do it this way, I think. Do it that way too. So either one of these two ways probably works. So this is the side effect, and then you're returning the notification, okay. So it's weird because it produces a side effect. And because it produces a side effect, it doesn't return like anything special, just a notification. Disjunction, conjunction, conditional, all return. Let's take a quick look at conditional. Right, so here, the example would be like that. And so then you're going to make this creates A, B, null is the default argument there. Yeah. You have two kinds of conditionals. You have a two-way conditional and a one-way conditional. Right, and so what do you have to do? You have to execute the conditional. This does not look like my code, but it's fine. If executing the conditional is the same as Jedi's true, then you execute the consequence. Okay? Else, if the alternative is null, right? So that's this situation. If you type in something like that, if false 10, which you could, right? Well, here, what am I supposed to do? You didn't give me an alternative. So here, what I'm recommending is we return the unspecified. Otherwise, we just execute the alternative. Okay. So again, it's a weird execute algorithm. Does that help on special form? Yeah. Yes, good. So let's see, fun call executes alias. So make sure you don't screw up the fun call. That's like kind of the most important one. My fun call is an expression. It's got an identifier and a list of inputs, right? So let's. All right, so an example of this would be add 2, 3, 4, 5, divide and 2. And so that's an example of a fun call. And when you parse it, you're going to be creating this. Parses to a fun call. The operator is add. Okay, and then here we have fun call also wants a list of operands. Okay, so I've got a list consisting of, add 2, 3 more. These are also fun calls here. Let's make it a little bit. These are also fun calls here, but it doesn't matter. It's just any list of expressions. Fun calls are expressions. Okay, and then fun call execute calls So because the operator is add, we're going to do ALU.execute calling add. But here's the part you have to watch out for. I'm not giving it a list of expressions. ALU execute wanted a list of values, remember? And so I have to, so 5 is 2 plus 3, 20 is 4 times 5, and 2 is 10 divided by 2. No, 10 divided by 2 is not 2, is it? 5. Right, and then this is going to return 30. This is what was typed in at the prompt. And alternatively, so both of these parse to the same thing. Both of these expressions parse to this exact same thing. Okay, it's just that, this thing gets turned into this thing here. Okay, so both of these expressions parse to the same thing, right? And so your job is, before you go to the ALU, is that you have to execute these operands, and that's called eager execution. And so think of it this way. You're so eager to know what your arguments are that you execute all of your operands, right away, whether you needed them or not. Maybe there's some, who knows, whatever this function is, maybe it didn't ever need this to know what's 2 divided by 10, right? But you're eager, so you execute it anyway. Contrast that with laziness, where you're executing from left to right until you know the answer, and then you just give up on the rest. Okay, so the fun call uses, I was about to say something profound about, oh yeah. Some terminology. And then I'll let you go. So here, these guys here are called operands. Okay, operands are expressions. These guys And so eager execution converts all operands into arguments as step one, even if some of the arguments were not needed. And when we get to Jedi 2, we'll be able to see examples of that. So programmers always get these things mixed up. And there are different terms that you can use, but I want you as people who've taken 152 to have some way of distinguishing the operands from the arguments. So the operands here are the expressions that are the inputs to whatever function this is. And the arguments are the values of those expressions. So what you're going to have to do in fun call execute is you're going to have to go down this list of operands here and execute each one to produce a list of values before you go to the ALU. Okay. Preprocessor before ALU will have a list of values to work with. Yes, so Jacob, that's exactly right. Is the list of inputs, values, or expressions, or a generic? Okay, I'm not sure I understand that earlier question, Jacob, about list the inputs. Okay, so can you do this Friday night? Have this working for me? Okay, good. Any other questions? All right. Saturday, no, I don't think so, because Thursday I want to get us started on Jedi 2, and that's going to be what I want you to focus on. All right, I will see you others. I'll see you all Thursday, office hours this week, and starting next week will be Friday, Monday, etc. All right, bye-bye.